Can you hear me? I think checking on my system, I think should be fine, isn't it? Can you hear me loud and clear? Okay, maybe one of you can reply to me using your mic. I want to check also whether my headphones are working or not. Any volunteers? Samuel, maybe check with you. Can you hear me?
Yes, sir.
Thank you. Okay, let's get started. So today, I think last week is it? Last week we finished the. I think your this is the class that actually have a replacement. I think I think some of you joined. Was it last week was I think Tuesday, and then some of you joined the other class which is on a Thursday. So we're finished with tutorial 2. So now we're moving on to a new one, which is tutorial 3. As you can see on the screen, this is actually, oh, Samuel, you're also one of the lucky few. Later on, you have to uh, talk to the visitors. I will also, I think, I think yours is later in the afternoon, mine is morning. Okay, as some of you may know, we are having visitors, 3 visitors, very important person coming to visit us to see our course, the program, whether what we are teaching is correct and the process is correct. So some of you have been invited to talk to them in the interview session. So back to this, we are, oh, I think you guys also, I think you guys are Tuesday, right? I think um, 31st is a holiday, and I'm not sure what week that is, whether it's an even week or the odd week. So it looks like we have to do another replacement. Again, this is part of the process. So we are not allowed to simply, how shall I put it, take leave, even though it's a national holiday. So we have to replace it. Right. So I think you're not alone. Lecturers also were asking what's the logic of that, right? Because it's a public holiday. Why do we have to replace it? So the answer is, since the course says that you have 14 weeks of tutorials, 14 weeks of lectures, so everything must be there, 14. No less, no more. I think more they won't complete, less they will complete. Okay. So back to this. So we are starting the tutorial 3, and I think from what question 1 to 7, those are the ones which are descriptive. That means you have to explain. Um, for example, what is Bayesian rule? So basically, you just have to uh, define, or not to say define. You have to explain what is Bayesian rule. So and then what is probability? Probability of an event. What does it mean? So probability of the event is the proportion of cases whereby, like for example, you throw a coin. I think a fair coin, not one that is doctored. So if it's a fair coin, if you throw it long enough, if you try it long enough, you will find that half the time you get heads, half the time you get tails. So that's what is meant by a fair coin, and what is probability. And then Bayesian rule, so very straightforward. You just mathematically define it as multiply by the what do you call it, prior probability of one of the events. For example, if you have a conditional probability of A given that B has occurred, right? Then multiply by the prior probability of the event B has occurred divided by the prior probability of event A. So that's straightforward as that. Now, before I go into that, so as I said, uh, see, the questions 1 to 8, 1 to 7, those are the descriptive type. And the answers actually are in the lecture notes. So it's just a replication, just a straightforward question from the lectures. But any of them you want me to go through? Any popular requests from 1 to 7 before I go into the calculation part? Now, the calculation part are the ones which we have not no time to cover in the lectures, right? So we will try it out in the tutorials. But again, as you can see, there's quite a number, and then we have only 1 hour. So other than rushing through, you find that we will not be able to answer. We will not be able to attempt all of them. So we'll pick a few to answer, and then the rest you have to try it on your own. So question 1 to 7, any one you want me to go through? No? Okay. So let's look at question number 8. You have this joint probability of hang on, of what you call it, of x and y, right? On the rows you have the basically, no, actually it's not rows. Actually, you can look at the columns. The columns are the probability of x1 occurring and x2 occurring. So this is a joint probability of x and y, right? So if you want to say what is the probability of x equals to, look at x, look at, sorry, look at, let me see if I can get this done. Okay, where is my pen? Okay, there it is. So what is the, so you can see here, what is the probability of x equals to x1? Let me check. Anyone, one of you want to ask any questions? Okay. Now, what do you think is the answer? X equals to x1. So basically, if you look at it, so it will be this is x equals to x1. Sorry, x equals to x1. So it will be, what do you think it is? Red color. So it will be this one. Oops, I need to change this. Okay. So this will be what? This will be 2426, right? Now, what about y equals to y2? So I just want to look at the probabilities of just y2, right? So again, you can see straight away. So this event, y2, actually you have given the condition, right, of y equals x1 and x2. But in this case, you just want to look at just the probabilities of y equals to y2 or y equals to y2. Let me just change this color, say this color here, right? So if you have, maybe I can just erase this. Where's my eraser is here. So we have it. Yeah. Now, what do you think? Any volunteers? Want to try? Very straightforward, right? So I think in the interest of time, I'll quickly go through. So y equals to y2. So it will be what? So this one, isn't it? So this will be 0.14 plus 0.32, 0.46. Now the other one, I'll use purple color. How about now? Now we look at the conditional probability of x1. Oh, y2 given that x1 is true, right? What is the probability of that? Right. So we look at the uh, probabilities of all the what do you call it? The all the probabilities of x1, right? So this will be equals to, if I can just draw it out. So this will be okay, because you see we are looking at all the probabilities of sorry, this is y2 and x1, correct? So y2 and x1. Now y2 and x1 is what? What's y2 and x1? Y2 and x1. Uh, 1, 4. Okay, okay, okay. So you have your, and then divided by, now this is only, this is, how should I put it? So basically this is the equation, the one way of explaining it. So this is your x1. Now what is your y2 and x1? So it will be, can you follow? Okay, so maybe
Sir,
yes, yes.
I need to divide by P probability
Okay, okay, good, good,
x1.
good. I was afraid of that. Thank you, Samuel. Good question. Let me just erase this. You see, y divided by x1, because you see, you look at it. I mean, I'm trying to explain to you in the logical sense. Uh, your what do you call it? Your your event itself, right? Your event itself, right? So where's my pencil over here? So you can see pencil. Okay, right. You can see. So we know that this is one of the events, right? Because we're looking at uh, y2. Oh, this is y2 and x1, isn't it? Right. So if we look at it logically, y2 x1 is only one of the many, one of the is it three? One of the three out of three, out of three, because you have x1, right? You have y1 and x1, then you have y2 and x2, then you have y3 and x. Oh, sorry. This is y1 and x1 again, x1. Let me just erase this. We follow? So you see, if you look at it, so we're only looking at this. Now, this is only one part of that event involving x1. That's why we look at, so this will be 0.14 now. So this one we calculated in the first part, right? Which is 0.26. So this one is, what's the number? Can someone help me to punch it up? Samuel, does that help you to understand a bit better? Right, so this basically what we're saying is that this is x2 and x1, right? So the x1 event concerning has three possible sort of combination. So you have y1, x1, y2 and x1, y3 and x1. So uh, y3, y2, x1 is only one of the three. That's why you divide by that x, all the x1s. Basically, this column itself. So can someone punch out the number? 0.53 ZG. Thank you. What is it? I need to check. 5385, is it? 5385. So 0 point. Now the next one, number 9. So you have so this is this. Okay, now this one, what do you think this is? So we are asked to calculate what is P probability of event B occurring given that A has occurred. Now, what does this remind you of? Right, what does this remind you of? This is basically your Bayesian formula, isn't it? Using the Bayesian rule, which is so to me actually I somehow find this quite easy to remember because it's actually if you want to so this is because this is unknown. B occurring given A has occurred. So this is unknown. So what is known? Known is will be this what is the probability of A occurring given that B has occurred? So to flip around, this will be P of B over P of A. Right. So how to remember that? I remember this by knowing that I always take this one, the last one, in the same in the same part, in the same row, if you like, they divided by the remainder one, which is PA. Now, then this will just substitute values inside. This is 0.5 multiplied by 0.4 divided by 0.3. Now, what do you get?
0.67.
6667 is two. I think it's two third. Am I correct? Let's
Yeah,
see.
yeah.
This is 1 point. Okay, two. This is 0.2, basically 0.2 divided by 0.3. This will be 0.666. If it's 4 decimal points, it will be round up the last one. Okay, time to change this to a different color. Okay, so thank you again. Okay, now this one's a bit trickier. So let's look at this. So the Dr. M knows that the disease is a something like a okay, never mind. It's a basically it's a disease. I think they call it disease of the it's a it's a it's a bug. I think. Okay, never mind. The disease meningitis causes 70% of the patients to have a stiff neck. What does it mean? It means that when you have the disease, one of the symptoms is that, or one of the consequences is that you have a stiff neck. The neck will be very stiff. When you move your neck, you find it's uh, painful, not sharp pain, but a bit uncomfortable. Uncomfortable. Now, in addition, Dr. M also knows that the chances of a person to have this disease is 1 out of 50,000. 50,000. While there's only one chance of people having a stiff neck, right? So the question is, assist Dr. M to calculate. Let me just erase this. I need some space here. I don't want to open up a new page. So at least you can see the questions. Okay. So hence assist Dr. M to calculate the percentage of a person having a stiff neck also has meningitis. Now you see you are confirmed to have the disease meningitis, then you find that you have a stiff neck. But then if I wake up one morning, I find like my neck is kind of stiff. I want to know whether I have the disease meningitis or not. So it's like a bit like saying the same thing with COVID-19. No, if you have running nose, what are the chances of you having the COVID-19? So it's a reverse now. You're not sure whether you have the disease meningitis, but you do know that you have the stiff neck. Okay. So how do we go about doing this? So let's call this. Let's write down the uh, numbers here. So we know that let's call this meningitis. What is meningitis? Which will be uh, okay. It's what 1/50,000, which is what This is about 0.002%, right? This will be 1/50,000. So you put down all the facts first. This will be 0.002%, which is about 2 times 10 to the power of -5, isn't it? That's the value. What else do you have? How about stiff neck? I'll call this stiff neck, 0.01%. This is again 1 times 10 to the power of 2 minus 4, isn't it? Then let's look at the actual now, the conditions. So you have your uh, the probability of uh, the person having a stiff neck, given that you have meningitis. So it says confirm you have meningitis. So uh, I think what is it also saying? It's saying that right. So saying that sometimes 30% of the time, right? Probability, means point 3. You have a point 3 chance you have the disease, and yet you do not have the stiff neck. Now this is what this is. Or maybe not do it this way. Do it the other way. This will be 70% or 0.70. So these are all your facts. So now what you do, you have to calculate the reverse now, isn't it? You are saying that what are the chances of me having the disease given that I have a stiff neck, right? So she also have meningitis. So stiff neck also has. So this one again, you just plug in your Bayesian rule. Good news is the equation is given in the exam. You just have to figure out what each of these characters means. Maybe I think we will in terms of A and B divided by P of S. So how do you do that? Okay, let me move down further. Okay, maybe I can move down over here. So the answer will be about let me see, where can I put? Oh, I have. I think there's some space here. So this will be 0.70 multiplied by P of M is what? P of M is 0 to the power of minus 5. 0.12345, correct? Divided by P of S is 0.004. 0.001, isn't it? Is it correct? Oh, sorry, my mistake, my mistake. That's my mistake. I wonder why the number so small. This is actually incorrect here. So I messed it up here. Okay, so this is 1%, right? And this is actually 0.01. So there's a few extra zeros here. Oops. Now, what's the number? What's the number here? Let me check. What do I have? It should be about okay, correct. GG, yeah, correct. So I think that was my mistake, right? Is it correct now? I think I just I'm mixed up. Is it correct now? Okay, thank you. So it's correct. So now the number is about let me see. What do I get if I punch it in? 0.7 times 2 times 10 minus 5. This one divided by 0.01. So this will give me 0.14%. Okay. So now this is interesting. Why? Now the chances of a person having the disease is I think 1 out of 50,000, correct? Which is comes to about 0.002%. It's only about compared against 0.001. 0.002%, right? But once you complain, you have a stiff neck, the chances of you having the disease now increase to 0.14%. Now, what does it mean? This is, if you look at the numbers, 0.14 divided by 0.002, how much is that? There should be, it's about 70, correct? So the chances of the person having the disease now, once you complain, you have a stiff neck, increases tremendously, increases by 70 times. So what does it mean? It means that the such a system, no, not system, based on this Bayesian rule, is a very powerful tool for testing of these diseases like meningitis. So, for example, if a person tests positive for HIV, it doesn't really necessarily mean they have the disease, right? Until they have these other symptoms, right? So, the first thing is that you can see here, the uh, the chances of a person having a disease is quite rare, only 0.02%, not too high. But if you complain, you have a stiff neck because stiff neck is one of the symptoms of your meningitis. So therefore, you can find that it's actually increased tremendously now. Okay, so this is I think what I'm trying to show to you is that this such a Bayesian rule is a powerful tool to help the scientists, doctors to actually diagnose. So I think that's why if you visit a doctor, I think they'll ask you for symptoms. So if you say you have a stiff neck, I think the doctor would probably want to check out, because the chances of a person in having the meningitis as a result of stiff neck actually increases tremendously, 70 times as shown here. This is actually, if you look at it, this is 0.14 divided by 0.002, right? So that's why uh, it's a powerful tool. Okay, now let me see. I think I won't go into this. Okay, let me go to the now this one's actually again this one's actually what it means is that a catch is something look like this. It's a tool, right? So this you put your hand here over here, and then you hold the this particular tool to actually probe whether there's a hole, there's a cavity in your tooth, right? So that's why the dentist use it to check. So of course, if you have if the probe, right, catches a cavity, catches the aching tooth, so of course it's very painful because it will then touch a nerve of your tooth. So this is I think this is what this table is saying that if you have cavity and then to check whether you have a toothache or not, whether you have this is there a cavity leading to a toothache. So of course, the catch that doesn't see anything, so it's okay. No catch, and then no toothache, right? And it checks for this. So these are the uh, three Boolean variables. The toothache over here, your cavity, and no cavity, and then your catch, right? So it's stable. So this is checking. So based on this, what is the P for what's the probability of a toothache? What's the probability of a toothache? So basically, what you do is that you have to check out. Okay, so this will be for the toothache. So over here, right? Oh, this is the one. Just erase this so that I don't confuse you. Oops. Hmm. So what do you think? So this is actually just checking for all the, again, this is similar to the earlier question over here, right? First one is x equals to x1. So this, in this case will be just the toothache. So you can see here, very interested in all this. So this will be 0.108. Oh, sorry. Maybe I'll look at this. Maybe I should draw it out. I should explain this way. So this will be equals to P of cavity um, and catch plus P again cavity and no catch plus P cavity, sorry, no cavity, right? They are this bottom row now, and catch plus your P of your cavity and no catch. Right, so this is all the toothache. So of course, if you do it for the no toothache, the same thing applies. So basically, it's this part here. That's for the other one. If you want to look at no toothache. Okay. So what's an answer here? Let's see here. Okay. Okay. So this one will be this will be 0.2. Now notice here, this one is a bold. So what it means is basically equals to P of cavity and no cavity. So what is it? So this will be equals to P of cavity will be and so equals to P this one. Let's look at this one first. So let's look at the first one. Cavity will go up. This is P cavity maybe I'll just erase this. So will be 0.108, 0.012, 728. Zero zero eight. So this is 230.200, right? And what is this? Basically, it is this right? This is cavity. But as I said, this is written in bold. So written in bold basically means that you take the cavity and also not cavity. This is you look at it. P cavity equals to true. That means that it's cavity and also false, no cavity. Okay. You can also do the same thing if you can also add up all this, right? Oops, sorry. All this, right? Or you can do the other way, which is once you calculate this one over here, right? So be 1 minus 0.2, which will give you 0.8. So this answer will be 0.2, 0.8. Okay. Now the third one, any questions so far? The third one will be the cavity and catch. Sorry, toothache and cavity, right? So again, we will look at it in terms of the look at it. This is in bowl, is it? This is in bowl. So cavity and let me just erase this one to clear some space. Sorry. Okay, still okay. Okay, okay. So this one, toothache and cavity. So you'll be looking at this part here, toothache and cavity, right? And also because this is a toothache and the 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 false part, so no toothache and no toothache and cavity, right? So this one will be what? What is the toothache and cavity? So we look at all the toothache and cavity, right? And then divided by all the cavity, which is I think we calculated in the first part. Right? So let's look at it first. So equals to so maybe I'll do it here. So C P basically toothache. Sorry, cavity. This is true. Equals to P of sorry. Maybe I'll just this one equals to cavity is what? Cavity is okay, right. So this will be, I think just now we look at this before, and then Simon asked the question, why is it you have to divide by somewhere up here, isn't it? This one I think, right? So we can basically use this formula. So we can use, so this will be here, this one, all the toothache and cavity, and then all the cavity, right? So this will be 0.108 plus 0.012 divided by I'll do it again, but I think we have actually calculated before here, which is 0.2, right? So we can do it here. So 0.108 plus 0.012. Now what else? These two, isn't it? Plus 0.0, because all this will be the cavity. Zero 0.72 plus 0.008. This will be 1, 2, isn't it? 1 to 0.120 divided by 0.200. Let me see what's the answer. This will be 0.6, right?
0.6.
Yeah,
Yeah.
thank you. Now, the reverse, right? Because you look at this, I think I'll zoom in again. If I can zoom in, control, I think it's control plus. That's my plus. Let's see here, this is actually polar, basically means it's a vector, both true and false. So basically equals to this probability of P of true. So you also need to calculate the reverse, which is a false. So far what we've done is that we calculated the true, right? So we calculate the true. So um, so you can also do the false, but the faster way will be what? 1 minus 0.6. Because both of these add up to 1, right? So this one answer will be, if I can move it over here, this will be 0.4, comma 0.6. This is both the too thick cavity and also not too thick cavity. Not too thick, no cavity. Right? Right, so it's a faster way, just 1 minus the 2. Now this one is actually or catch. So the last one is P probability of cavity and too thick and catch union, right? Let me see here. Okay, hang on. Let me just. Okay, the last one. Last one is. Let me get a drink first. Now, what is the probability of two fit? Right, probability of two fit, which calculated in the part A, which is 0.2. Okay, I need to erase this again. Running out of space. Control minus, increase it. Here. Erase this. Okay, so we're down to this one. So the probability of your two fit, right? So we have to first of all calculate what is the probability of the two fit. This is 0.20. This is here, right? So what we're trying is to calculate the right-hand side first, the part first. So this one is a union of two fit and catch. So P of equals to P of your two fit plus a P of your catch. Now P of your catch 72144. Right, so you can see here. Now two fig is actually we know it's 0.2 from the first part. Now what about two correct catch? Catch will be P of catch. Union of this here plus catch So it should be 0.072 plus 0.144. Let's see why is that so. So equals to this is 0.20 plus your catch, toothpick and catch. Hang on, let me see why is it. I got the answer is actually 0.072 plus 0.144. This is your D, isn't it? Right? So your toothpick and catch. Okay. This is the P2 figure. So okay, right. So okay, let me explain. Now we have actually point. What is point two? Point two will be your this part, isn't it? Let me see. This is your toothpick, right? Toothpick over here. Right. So we have actually calculated the toothpick, right? With all the catch and also not catch, but this is a toothpick part. Now, if you want to look at only the catch part, the catch, right? Because here you can see toothpick, the all catch. Actually, this is all, isn't it? Sorry, this is actually all. So what's left? Left is only this part, right? So toothpick, everything covered. So what's not covered will be the not toothpick and catch. So this one is not this one. So we'll only look at this catch part. Is it clear enough? Any comments? Right? That's why we take these two. Right? So this will be either the toothpick. This is the all function. This is actually the what do you call it? I think all function. This is all toothpick or catch. So that's why you get this. I can change back to my uh, pen. Now what is this? 2, 1, 4, 4, 6, 2, 1. Right? So this is 0.416. Okay, so far so good. 416. Now then you have this. We still want to look at the. Uh, okay, so we are looking at the probability of cavity given that you have toothpick or catch. That is the question part D. So we're now looking at this one cavity and this. We wanted this one. Let me just erase this again. So we want to look at this. Your cavity mm. This is your N now. And then your right. Now what is this? Cavity and that. So this will be the first three columns on the first column. So 18, 108, 0.012 plus 0.072. 0.12. Okay, right. So it's the first three columns on the first row, right? So this is just erase this. Cannot erase. Sorry. So this one should be good. Okay, this should do it. Okay, now I can also erase this. Otherwise, okay. So this will be cavity, cavity, and this also be cavity. Okay, right. Why don't we consider this? Why are we taking this? So we are taking this one, and this one. Why not this one? Because this is not catch, so it will not qualify. So it's only for catch or two fake. So two fake will be these two columns. Okay, and then this one will be the this third column here because it's catch. So this will be so give me a minute. So give me what's the value?
0.192, sir.
Wow, 192. Thank you, Samuel. This is uh, okay, 192 is good enough. So we keep it some up here first. So we're still looking at this. Okay, right. So let's go back to the basin again. So we have this. So let's call this A and call this B, right? So P of A given that B has occurred will be what? Equals to P of B A times P of A. Sorry, this is not the basin. This is actually this one is another one. So yeah, so this is let's call this okay, there you go. This one is A, B. So P of A and B equals to, I think this one we have calculated before. Okay, this is actually this. A and B divided by P of B, all the B's, right? B would be your, right? So this is your 0.12 equals to 0.192 divided by P of B. B is what? B is your two fake or catch, which is your 0.416, which we've calculated just now. I think we calculated this before. 416. Let's see, P of B, two fake or catch, which is here, right? So let's see here. 108, 1272. So correct. P of B, two fake. Oh, sorry, I missed out. Actually, it's this four. So it's actually oops, just refuse. Okay, this one, and then you have two fake or catch. So it's these two, right? These two again. So you'll be your 108, 121664. This should be 2, isn't it? 0.2, right? Then okay, 20, and then your 72, 72144 will be 416, right? Oops. So, okay, so what's the answer here? Let me check. This should be 4615 if you catch it to be what I got 4 decimal points. Okay, so this is 4615. Okay, this is it's a bit lengthy, so we have to actually you have to basically be a bit careful because as you can see, you can actually quite easily make mistakes. Let me erase the screen here, leave some space for us to calculate the next part. Now we're moving to the certainty factors theory, right? So we have here. Oh, sorry, we have quickly. Yeah. So this one is okay. Maybe I'll do this way. I will give you the answer, and then I think you all have class after this, or can I take another 10 minutes of the time, or must I stop here? No class. Okay. Okay. Thank you. I will carry on. So this one is so I'll quickly finish this one and then look at this. So here we are looking at the certainty factors. So the rule number one is if P, then N is true with a certainty factor of 0.5. Rule number two, if Q is true, then N is true with certainty factor of 0.9. The last one is if N is true, then X is true. So you can see what can you see here? So if I would draw it out and as a figure, this one doesn't work. It's not so sensitive. So you have here P is true, then contributes to N, right? And then Q is true. My PC not so good, not so acting up this morning, right? And then N is true, then X is true. So we can see here, N is a result of a parallel combination, right? So then the first part here, what is it? So we look at the parallel combination. So if we look back, if we look at the formula, it will be C1, C2 minus C1 times C2. So this is basically, again, the rules are given. So first, this is so your CF1 plus CF2 minus your CF1 times your CF2. This is your parallel combination of here. So we have two of them. So we just put this inside. So what you get? You get 0.5 plus 0.9 minus 0.45, correct? So this will be 1.3, isn't it? 1.30, oh sorry, 1.4, right? 1.4 minus 0.45, you get 0.95, correct? Right, this is your answer. So will be 0.95. This will give me, so you get 0.95 here. This is your certainty factor, right? Then the next part here, as you can see, this one actually uses your series in series. So this one will be just basically your 0.99 multiplied by your 0.95, which will give you 0.94. So certainty factor you can see actually is a bit more straightforward, right? So this is multiplied by 0.99. So the answer will be what's the answer? 0.94. So you get your 0.94. Now, what is the based on the result here 0.94? What is the final decision? So if you only will do something if it's more, the threshold is 0.75. So you can see here 0.94 is more than 0.75. Therefore, it is you proceed, right? So you proceed with X over here because now it's actually 0.94, which is higher than your 0.75. Now, what happens if R2 is removed? That means R2, this rule here has been eliminated, gone. So you have only two rules, 1 and 3. So here, if it's 1 and 2, so you will have basically a series combination now, which is 0.5, uh, sorry, 0.5 multiplied by 0.99. Now, what is that? That is given to 0.495. Is it correct? Let's see. What's the value I got? 0.95. Right. So now, again, what's the effect of if R2 is removed? So if R2 is removed, your certain factor for X is true is only 0.45, 49495, which is close to zero point 0.5. But your threshold is 0.75. Therefore, you will not proceed with X because it's less than 0.75. So you can see that the effect of the removing, right? So think of it as maybe sensors. You have two sensors coming in, and then they contribute towards N. But one of the sensors has been removed. This is removed. This output from this sensor is removed. So you don't have that. So it's only 0.5 multiplied by 0.99, which is 0.95. So therefore, you find that your decision has changed now, right? So I think we stop here. This one actually, I think, wait, I'll give you the answer for this, for question 14, A and B. Okay, let me check what I have. A and B, so A would be point 2, and then the one is, okay, 0.2, 20, 13, 80. So the answer is, this is 20%, answer is 20%. Now, if you were to calculate all this out, it will be, this is Huawei. This is 20%. This is 13.3%. And this is 80%. Okay. Based on this posterior probability of the condition, so you can see that what is your recommendation, right? Based on this, what should you do, right? So since you have three different suppliers supplying your components for your handphone, right? So you have three factories: Huawei, Huawei, and Weiwei. So you can see that uh, only Huawei, the one in the middle, has the lowest number of defects. Weiwei is the worst, 80% defects contribute towards your final product. So think of it as your different suppliers, right? So for example, you only accept the parts from Huawei because Huawei only has, is the better of the three suppliers, right? And then, of course, you have your, then maybe you can also ask Weiwei to learn from Huawei how they actually managed to have such low defects. Okay, so we stop here. And I think for the rest of you, I'll see you tomorrow morning. Don't forget this extra briefing at 9 o'clock on the assignment, right? And for Samuel, good luck on your interview this afternoon. The rest of you, any other things before I stop here?
Sir,
Yes,
so what is the answer for question 12B?
12. Oh, this one, here is it?
Yes,
This one. You see, basically your part A, you get 0.94. What is the final decision if the threshold of your system, which is X, whether you proceed with X or not, right? So X will be some event, something you need to do. But after the calculation, you find that it's 0.94 and your threshold is 0.75, right? So 0.94 is higher than 0.75, so you have a higher degree of certainty. So you will proceed compared to the last part C. Part C is only 0.495. Part C, no go. Whereas part A, proceed. You follow?
yes, sir.
Okay.
Okay.
So basically, it's once you calculate that, and then you compare against your threshold. If a threshold, of course, the threshold is up to you to set. You can set a higher threshold, you can set a lower threshold. So in this case, the threshold is, say, for example, 0.75. So based on that calculation on the certain factors, what should I do with X? X can be, to buy, for example, to buy a share, right? So it can be shares or it can be other things. So you can see that 0.94 is quite a good value. So you can see that 0.94 is higher than 0.75. Therefore, the final decision is proceed with X. So X is you can trust the X and do something with that event X. Okay, we stop here. So if there are no questions, I'll see you tomorrow morning. Okay, bye bye.